Okay, so in the previous video we walked through the explanation of the open loop versus the closed loop. This is going to be our open loop. So let's rock through this guy. We've got our standard forward and reverse contactor diagram above with stop, forward, and reverse, electrical interlocks, and we've got a mechanical interlock between the forward and the reverse. The overload is often placed over here in the textbooks, but again, the overload can be here or it can be over on this side. Either side, it takes out the feed for the rest of the circuit. So we're not going to make use of the overload yet, but we are going to make use of the stop, the forward, and the reverse push button. So the stop is going to go into input 0. Everything starts at 0, in this case goes up to 15, so 16 bits per word. And on that word we have 16 inputs or 16 bits that we can use. They always start at 0. So I'm going to use the normally closed stop push button and bring it into input 0. I'm going to use the normally open forward push button, put it into input number 1, and the normally open reverse push button, put it into input number 2. Now I've just grabbed the exact same switches as I have up here because that's the way they were wired before. With PLCs, this could easily be a normally closed, we just have to change the addressing in our program. But for beginners, we're going to start off with the same switches as we have in our standard diagram here. Okay, remember from before that an XIC is looking for the presence of voltage or the presence of 1 or that something's on. An XIO, an examine if open, is looking for the presence of no voltage, a 0 in the memory, or that something's off. Okay, so for this first guy, we've got the stop going into input 0, right? And right now we have that voltage being impressed across input 0. And I'm going to use an XIC. I'm going to make sure that that voltage is still there. For the forward, I have to wait until somebody presses that push button. When they press that push button, the 24 volts will be impressed on this input number 1. So again, I'm going to use an XIC. An XIC looks for the presence of voltage or when there's a 1 in the memory. Same thing for the reverse. For the reverse contactor to turn on, I have to have somebody press this push button. When they press that push button, the 24 volts will go to the input, and I'm going to use the same XIC and look for the presence of voltage there. Okay, here for the reverse coils, I'm going to use the electrical interlocks in my program as well. And then again, the last thing in our program is always going to be our outputs. If you try to put an input on the right side of the output, it's not going to work for you. So now addressing for these guys, the first one, so let me grab a red here. What we'll do is we'll go through and we'll address each of our different inputs there. So on the Allen Bradley, I have input : 0.0. So I have input : 0.0. And then there's a slash, so a backward slash, and then whatever bit, forward slash, and then whatever bit you are looking for. So this guy is going to be bit 0. Okay, so again, this guy here for the next one is going to be input 0.0. And then we're going to look at the first bit, or I guess the second bit, but input number 1 here. And then for the reverse, didn't leave myself much room, but this guy is going to be the input 0.0, and we're going to bring it to input number 2. And those are going to be the only inputs that we're going to make use of. Okay, so you can physically put your inputs here on your diagram, and then you can transfer them over here if you want, just so you got as much information as possible on the page here. Okay, this guy here is going to input 0.0 number 1, and then 0, and we're going to input number 2. I believe that this number right here is corresponding to like the card. In this case, it's a microcontroller, so it doesn't have a card. But like for that word is being described right here. So we're on the first word, and then the first bit, second bit, and third bit on that word. Okay, we can transfer those guys over to our program now. So here we've got input 0.0. Over here, again, we've got the stop, and we can make use of that stop as many times as we wish. Okay, so the logic is no longer the path of current, it's the path of logic. So we're just looking for the presence of 1 or the presence of voltage at each of these guys. The forward push button is going to 0.0, and we physically wired it to the first input, so we have to look at that bit of information. And the reverse push button, we've got wire to 0.0 and, oops, come on, 0.0/2. Beautiful. And those are the only inputs that we have so far. So this is an open loop in that we're not actually looking at the forward coil holding contact to see that it's turned on. We're going to make use of the output. And so we'll address these guys for our outputs, and then these two holding contacts are going to be addressed the exact same as the outputs. So when the output turns on, then we'll look for the presence that something is actually turned on. So we'll look at the same address there. And it's just looking in the PLC program to see that that output is actually turned on. But we don't even know whether the coil is actually pulled in. There's nothing out in the field that's sending a signal back. So this first part is just an open loop for our forward reverse. Okay, so just to rock through this guy, our output here is going to be output : 0.0. We're going to have this guy coming off of the first output. And actually, wait, I've done this before where I'm on cruise control. It looks like I have the forward wired up to output number 2. So that guy right there has to be output number 2. Okay, so be careful that you're not on cruise control like me. You have to address it the same as the actual terminal that you wire to. Okay, so my forward contactor is at output number 2. All right, so I'm going to address all of these guys the same all the way through. Now, you don't need to do this. I just like to do this so it has all the information on the page. And the reverse is physically wired to output number 3. So we'll address that guy as our third bit of information on our output data table. And again, I'm just putting all this information everywhere so that I can reference it later on. Beautiful. Okay, so those are all our outputs, and we don't have a holding contact that's going into the inputs, so that's everything. The last thing we need to do is just address each of these guys, our electrical interlocks and our holding contacts, and they're going to be addressed with these same output bits that we just looked at for the forward and the reverse. Okay, so let's start off with the forward coil. This holding contact right here is just going to say, all right, when this guy turns on, then examine that it's on. So we're just going to look at that bit of information in the computer or in the PLC, and we'll address that guy as our output. So that when this turns on, this is true and provides us with another path of logic to keep that guy on. Okay, for the reverse holding contact, we're going to do the same. We're going to address this the same as our reverse output. And then each of these guys are also going to be our outputs. So for the reverse coil, we're just going to look at whether that reverse has actually turned off. And over here, we're going to look at the forward coil. And we're going to make sure, all right, is the forward coil off? If it's off, then we can turn on our reverse coil. Okay. Again, for each of these guys, not much room down here, so I'm going to leave those addresses off of here. But again, we've got the same addresses here and here as well. All right, guys, let's take a look at our program now. And this is a good idea in the beginning to write everything out and to have your diagram above, have all your inputs on one side, have all your outputs on the other side, and then try to put your program in the center. That way, on one page, you've got all the information that you need and reference for the rest of the project. All right, let's take a look at the actual program, guys. Okay, so first thing we need to do is we'll open up RS Links. We're going to go here to RS Who, see who's on the network. So we're going to open this guy up right here. And there's our computer, and there's the Micrologix 1200. So it seems like everything's talking to each other. So let's drop this down. We'll minimize this. Next thing we'll do is we'll open up RS Logix now. Okay, let's make this a little bit larger. Now these steps we're going to save at a certain point because this is going to be the same setup every single time we do a lab. So we're going to go here and we're going to open up a new. The processor that we are using is a 1200 series C. So we're using this guy right here. We'll hit OK. Brings up everything that corresponds to the 1200 series C. And the next thing we have to do is we have an analog card that's connected in beside. So we're going to read the I/O again, and there it brings in the analog. If you don't do that, you're going to have that red fault light screaming at you when you try and download your program. So everything's set up now. The exact same thing is going to happen every time you do a program. So why don't we save that? Whoops. That's save as, and we're going to save that as a basic setup, right? That way we can open up the basic setup. It's got everything set up already, and we can resave as, you know, the 3-wire, the forward, reverse, the timer, the counter. Regardless, this is our basic setup, so we will have everything mint every time we open that guy up. All right, so we're going to drop in our program for the forward, reverse contactor. So this is our end. We have to put in a new rung. And let's see, we've got the stop, the forward, the reverse holding contact, and then finally our output is the last thing to go on the right hand side. In parallel with the forward push button, we're going to have another examine if closed. Who knows why it puts it over here. We're going to grab this with the left mouse, bring it over till we see green, and then again we're going to highlight this side and drop in an XIC. Come on, buddy. There you go. All right, so we can put in all our addresses now, but ain't nobody got time for that. Why don't we just copy and paste, because the forward and the reverse have the exact same instructions there. Excellent. Okay, now we're going to drop in our inputs. So our inputs here, we had input 0 as the stop push button. So we'll say stop push button, and then we'll say it's a normally open as well. Might as well give ourselves as much information as possible. You can put the normally open here in the description as well. The next one is the forward push button. So we're going off of that main diagram that we just drew up with all of our inputs, our outputs, and our program on there. And then finally, this is our reverse push button, and it was a normally open as well. Beauty. Those are the only inputs because we're doing an open loop at this point, so we can close this guy up. We have 2 outputs. I was on cruise control before, and I was going to grab the 0, but then I clued into the fact that my forward contactor is actually wired up to output number 2. My reverse contactor is physically wired to output number 3, so I got to make sure that these are addressed exactly the same. Okay, once those are there, I can now grab this output for this reverse contactor and bring it over, and I can grab the forward contactor and I can drag and drop here as well. I love the Allen Bradley in that you can grab it and just drag and drop, and everything's over here for you to grab easily. Okay, the other thing that's cool about the Allen Bradley is that when you scroll down here, once you've done all those symbols, you can go here to your address symbol picker, open this guy up, and everything you've just done is alphabetically labeled here. So if we wanted to grab the stop, we can drag it till we see green, drop it in, and drag this guy over. Then we don't have to worry about addressing or anything like that. It provides everything mint with the addressing. Okay, so our forward push button, normally open, is going to go, oh, I missed it, left click here, grab it until you see green. Okay, reverse push button, normally open. I don't know what's going on. Let's go, come on. There we go, okay. And then this is an open loop, so we're going to address these guys the same as our output. We're not physically looking to see whether the holding contact is actually closed, and we don't have any overloads in our program yet. Simply an open loop now. So the forward contactor is going to go here. Oh, look at that. See, I was on cruise control. I grabbed the wrong rung. Forward push button, normally open. So be careful. You don't grab the wrong one. Stop, forward, forward. Okay. Whoa, what's going on? Must have been drinking here while I'm doing this video. Stop, reverse, and reverse holding contact. Where's my reverse holding contact? There we go. Okay. Stop, reverse, reverse. Stop, forward, forward. Okay, everything's cool now. Okay, my reverse contactor is going to go up here for my electrical interlock, and my forward contactor is going to go here for my electrical interlock, and that you have the normally closed from the opposing contactor in series with each. So here the normally closed from the opposing contactor is in series with the forward. Okay, now everything's set. Next thing we're going to do is we're going to come up here and we're going to verify the project, make sure everything's cool. Okay, there's no errors that are found. So now let's download this guy. And we're going to hit OK a number of times. There's another way to download this to be safer, but for us, we're just connected in with a serial cable, so we don't have to worry about sending the wrong program to the wrong PLC at this point. Changing back to run mode, yeah, that looks good. Go online, yes. Now, some of your PLCs have gremlins in them, and they will do this. You'll say, do you want to go run? Yes, and then all of a sudden it does this, and then nothing's coming in. So again, you have to click on this and make sure that you are in the run mode. 80% of the PLCs will be fine, but the other 20% will have gremlins in them. Alright guys, let me pause the video here. I'll grab the camera and we'll do a picture-in-picture, and I'll put the PLC here, and we can see how the inputs change, the LEDs change, and our I/O table change. Hang on for a minute. Okay guys, so now everything's set up. What I'm going to do is I'm going to hit that stop push button first, and we're going to see it change in a number of different places. So let me open up the input data table here, and we'll bring this guy over here. There we go. Can we make this a little bit smaller? Let's see. Come on. There we go. Okay, so we've got our input data table here, and so let's see. We've got the first word here, and we're looking at that first bit right here, and that's our stop push button. So when I press that stop push button, watch, it'll change to a 0 now. There you go. And you'll also notice that as it changes from a 0 to a 1, then this guy, the examine if closed, will change as well. So right now there's a 1 in the memory, right? So there's voltage at that terminal, and we can see that there's voltage at that terminal because that LED is on right there, right? So input 0 is seeing 24 volts. We're using an examine if closed to look for that 24 volts, so it's true. As soon as I press the stop push button, there's no longer 24 volts. This light is extinguished, and you can see that right here, this is no longer true. So if I press that stop push button, then it will turn off that forward contactor. Okay, next thing I'm going to do is I'm going to hit the forward push button, normally open, and we had that wired to this guy right here. So you'll see that when I press it, it goes to a 1, and you'll also see that this goes green. Okay, so have a look at the data table and at the forward push button, normally open. There we go. So you can see that it's turned to a 1. It's green here. My contactor has turned on. I'm now going to let go of the push button. That's, no, well, that's interesting. Let's try that again. Turning on. And then turning off. Well, what's going on? Well, that's strange. Look at this. I thought I had everything set up. I don't know, drinking today or what's going on, but this guy is not my forward contactor. Now, when issues like this come up, I have not been able to find a way that I can change this on the fly. I can edit the symbol. I can go to the database, data description, cross-reference, data table. But I can't seem to be able to change this on the fly. So if you have a way to change this on the fly, I'd really appreciate it. Let's go offline. Let's change that back to, so that was not an input, that was supposed to be an output. So I said that that symbol picker was going to make things easier, but I ended up screwing up quite a few things. So this guy here, I need my forward contactor to be here. Okay, that's good. Reverse contactor. Okay, I swear I looked at this earlier, but let's try it again. Okay, so let's download this guy again. It doesn't take too much time, but to be able to change that on the fly would really be helpful. All right, let's try that again. Let's open up our input data table. Let's bring this guy over here. Let's make this a little bit smaller. There we go. And so we're going to do this guy right now, the forward push button. We'll see this change, and we'll see this change as well. There we go. So it changes to a 1, and when I let go, hopefully it will hold. Yes, there we go. So you can see me changing the forward push button. It has no effect on this circuit now because I have logic continuity in that this output is on, and this is looking at that output and examining if it's on and providing another path of logic to keep it on. Okay, if we take a look at our output data table, then we can see here that this guy right here, my forward contactor, is now a 1. And when I press that stop push button, it will go to a 0. There we go. Okay, so this is my forward turning on, and then forward turning off. Excellent. Okay, so this one right here is just looking for the fact that this is a 1 in the memory. Okay, let's try the same thing, but we'll go for the reverse now, guys. So again, hitting the stop push button will change both of the rungs, any rung that stop is on. Okay, when I hit the reverse push button, then this will be true. We'll find that this goes to a 1. So let's do that now. See, it goes to a 1. I'll let it go. Goes to a 0. But now we have that path of continuity because the reverse contactor on 3 right here is now a 1. We're examining that it's a 1, so we have another path of logic for it to turn on. Beautiful. Okay, let's hit the stop button and we'll see that output number 3 goes to a 0. Beautiful. And that's basically it. I mean, the only issue is that while it's running, I have no way to know whether that contactor has actually pulled in, right? I don't have anything out in the field that's sending another signal in. Like I can physically push the forward contactor in right now, and you can see that light right there, input number 5 is changing, but I don't have input number 5 in my program. So I don't see anything, right? So right here, this guy is changing, right? But that's not part of my program, so I don't have a closed loop to actually see that it's pulling in. My reverse contactor is right here on input number 6, right? So we can see that changing, but again, I haven't made use of that in my program whatsoever. So you can see that LED. So the next step is to bring in those holding contacts and to bring in the overload. So we've got to hook up our overload as well. And somehow bring that in part of our program so that if we're in an overload state, here, let's do that. Let me just trip the overload for 2 seconds. Okay, so I'll get it going and forward now. And what I'm going to do is I'm going to trip the overload that corresponds to that forward contactor. And when I trip it, you can hear the contactor pull out. So the contactor has pulled out. Let's see if we can hold it there. But you can see that the PLC is still trying to turn it on. So if I reset that overload, then it pulls right in. I don't want that. I don't want the motor to turn right back on after an overload state. So that's a little bit dangerous, having the contactor turn on. Again, here's an overload, kicks out my contactor, you can hear that. But the PLC is still trying to turn it on. I don't want that at all. I need to have another instruction here for the overload to send a signal into the PLC to turn that off. Essentially, it's going to act as the stop push button and turn it off. All right, guys, let's stop it there. Any questions you can leave in the comments, or we can talk about it in class. So the next thing we're going to do is do the closed loop for the exact same circuit. We'll see you in the next video, guys.